Hello, good afternoon, students. So, in structure of atoms, today we will start the shapes of SPDF orbitals. Let's first we talk about the shape of s orbital. In a s orbital, two things is coming, 1s, 2s, this type shapes are coming, and they form a node. Okay, so let's start with the 1s orbital. Let's see here. The density of the charge cloud is greatest at the nucleus and decrease with the distance. You can see this thing here in the between this one side. This is said to be the nodal plane. What it said? It's said to be a nodal plane, or we can say it is a cloud. Okay, it is greatest at the nucleus and decrease with the distance. When the distance goes on decreasing, this is also goes on decreasing. The density at a particular distance is uniform in all derivation. Therefore, is I, that is 1s orbital is spherically symmetrical. It is having not more shapes, it is only a symmetrical shape. Okay, so this is 1s. It is not coming in the paper, but for the information you should know this thing, that how is the 1s orbital formation takes place. Next thing we are taking about the 2s orbital. The density of the charged cloud is greatest at certain distance. Means you can see on this one side, it is having a greatest distance. Between these two having a greater distance, you can see this one. The distance between on this line, this one line, and this one having a less distance. On this one you can see from here till here having a more distance. So they are having a certain distance from the nucleus and a small, and it is small. It is small. In the other regions, 2s orbital is also spherical symmetrical. It is also symmetrical. Now the word I am saying that nodal plane. So what is the meaning? Nodal plane is a plural form. Now what is node here? There is a spherical shell within the 2s orbitals where the electron density is 0. One spherical shell is there. Spherical shell, this type of a spherical shell. Within the 2s orbital, means inside the 2s orbital, in which the electron density is 0. At that time, what is the electron density is 0. This is called as node. What it is called? It is called as node, and this plane is called as a nodal plane. This we are talking about the s orbital. Right? Now the important one which is coming in the paper. Understood? What is that? That is the p orbital and the d orbital. Students, okay? Now you can see shapes of p orbital. They have different shapes because they are not spherical. They are not definite shapes. They can change their shapes, but are concentrated along at a particular direction. They remain in a particular direction. The 3 2p orbital have a small dumbbell shape, but their directions are different along x, y, z. In this one, what we have to do? You can see here, P having a 3 things. Px, Py, Pz. Fine. By these 3 things, we are saying it having a 3 orbitals. When we are making the orbital, we are making a 3 orbitals here. P having a 3 orbitals. 6 electrons are coming inside it. So the shape's formation takes place. You can see the shape. This is the shape. This one side you can see the x, y, z also. Means it is not a fully symmetrical, but it changes the direction. So here you can see it change the direction, but other things are same. So this is the shape of the p orbital. Okay. Next is shapes of d orbital, which is very, 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 very important. Okay. In this one, the 5g orbitals designated as, now beta, d orbital having 1, 2, 3, 4, 5. Fine. We can say this thing dx, dy, dz. Okay. Next, dx square by square, dz square. Chemistry is very easy subject. Okay. So don't take a more pressure on your mind. Okay. In a laughing mood we will study. Okay, fine. Don't take that this is too much burden is there. No. Chemistry is very, very easy. Okay. So what is the shape here? Shape is dx dy dz. Now how we can form as dx by z zx? You can see here x by formation takes place by this, by z formation takes place by this, z by formation takes place, dx square minus by square is there, and dz square. So first of all, these one shapes which is formation takes place of x by z, that is said to be the dumbbell shape. What the shape? Dumbbell shape. Okay. Next two orbitals, this is very important one, that is called as double dumbbell shape. In a question it is coming, one question arises here. In a d orbital, which one is a dumbbell shape? Make a diagram. In a dumbbell shape, the orbital remain on this one side, means this is lobe is present here, lobe. Okay, this lobe is present here. And the direction where the two things are going, you can see here, two things are going this one side. By the mix, two things are mixed, forming a one. It forming a one here and here. Understood? So it form a shape of the d orbital. Understood, students? Okay. Now, after this, I have given the lecture to you on the Bohr model also. Okay, subshells and shells. On that day I have told to you that it is of, in small classes 9th standard, subshells are S, that is the K, L, M, N and so on. Here it is S, P, D, F. Okay, this revision I am going to do. Okay, after this, in a SPDF, S having a 1 orbital, P having a 3 orbitals, P having a 3 orbitals, and D having a 5 orbitals, F having a 7 orbitals. Okay, now I am going to tell you about this also. S, P, D, F. S having a single, this having a 3, 1, 2, 3, this having a 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, this having a 7. Okay, chemistry is very easy. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 here and 7 here. Now, these are the orbitals which is present in SPDF. Now, what about the electrons? In this one, the 2 electrons are coming. In this one, first you can see how I am filling the electrons. Okay, first 1, 2, 3, 4 will come here, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here how many electrons? 14 electrons come here. So this already I have told to you in concept of shells and subshells. Fine. De Broglie also I have told to you. If you understood this thing, that a de Broglie I have told to you. In a de Broglie, the formula is coming as delta is equals to H over mv. If you know this thing. And this H over mv, we are writing this thing as a momentum P. Okay, de Broglie. After that, I have completed the Heisenberg's also uncertainty principle. In a Heisenberg uncertainty principle, it is said to be delta x, delta p, it is larger than equals to h upon 4 pi. Okay, I am also doing the practice, that's why I have learned these things now. Okay, now I am not using any book. What the revision I have done, that revision only I am giving to you. So as I am doing the work here, you also have to do. Work hard, then you also will speak like this, how I am speaking. Next is, now beta, see on this P. Delta X is writing here. For this P, we are writing as M delta V. greater than equals to h over 4 pi. Fine. Delta x, delta v between multiplication sign, which is equals to h over 4 pi m. Okay. This h is said to be the Planck's constant. Okay. M is said to be the mass, and pi we can say 22 upon 7 or 3.14. This you have studied in the science also. Sorry, in the maths also. So this, what is this? This one is the de Broglie. This is the Heisenberg uncertainty principle. Fine. Uncertainty principle. Understood, students? So today we have completed the shapes of SPDF, and the revision we have completed. Heisenberg uncertainty principles we have completed. Now tomorrow I will start the above principles, Pauli's exclusions, and quantum numbers. Okay. So students, please write things in your copy and complete your work. That was your homework. Okay. Thank you, students, and have a nice day.